Let's take a look at this example. I would start solving this problem by labeling these 2 points, point A and point B, and simply write that VA is the voltage from this point to the ground, right? VA is the voltage across my voltage source 1. So I can say this is my voltage source 1, and this is voltage from this point to ground. Okay, this ground and this ground is the same ground, so this is also my V1. This is voltage across resistor R1, and this is equal negative 16 volts. Why? Because this voltage source is connected to this point by negative terminal, and the other terminal is connected to ground. Okay, so this is my VA. VB, okay, VB is voltage from this point to ground and from this point to ground. So I don't know voltage across this resistor, but I know that the voltage from this point to ground is equal negative 5 volts. Why negative? Because this point is connected to the negative terminal. That's why I'm going to say that this is equal my voltage source 2, and let's put, and because this is connected negative, so just put negative and negative over here. Okay, so this is also equal to V3, which is equal negative 5 volts. Okay, keep in mind that this ground and this ground is the same, so if I have voltage at this point, from this point to the ground, negative 16, so it means that I have from this point to this point also negative 16, because this ground and this ground is the same. Okay, if it comes to point B, from this point to ground I have negative 5, so because this ground and this ground is the same, so then this is the same B point, so from this point to ground I have also negative 5 volts. Okay, so we have voltage VA and voltage VB. Next, we're supposed to keep in mind that when we talk about the current always goes from the higher potential to the lower potential. Okay, so if you want to set up the direction, if you want to determine the direction of the currents, we're supposed to keep this always in mind. So let's take a look how it works. Now we can find the current which goes through this resistor. Okay, by simply finding the voltage across this resistor first. So VAB is equal VA minus VB, where VA is equal negative 16 volts minus negative 5 volts. So VAB is equal negative 16 plus 5 is equal negative 11 volts. Negative 11 volts. So on this side I have negative 16, on this side I have negative 5. So negative 5 is greater than negative 16. That's why my current is going to go in this direction. This is my I2. Okay, now at this point I have voltage negative 5 volts, right? Negative 5 volts, and over here I have what? 0 volts. So 0 is greater than negative 5, that's why this current is going to go up. So this is my I3. At this point I have negative 16. Negative 16 is less than 0, that's why this current is going to go this way. This is my I1. Okay, so let's find I1 first. I1 is equal V1 over R1. V1 is equal negative 16 volts over R1, 3 kilo ohms. So I have 16 negative divided by 3 exponent 3 equals negative 5.33 milliamps. Next, we're supposed to find I2. I2 is equal V2 over R2. In this case, this is going to be my VAB. VAB over R2. VAB we found is equal negative 11 volts over R2 1 kilo ohm. This is equal negative 11 milliamps. Alright, so now we're supposed to find I3. I3 is equal V3 over R3, and this is equal V3 we said is equal negative 5 volts over R3, which is equal 4 kilo ohms. This is equal 5 negative divided by 4 exponent 3. This is equal negative 1.25 milliamps. Now we're supposed to keep in mind that the current flows from the positive terminal to the negative. Okay, we use the conventional current flow, so that's why the current is going to be pushed by this voltage source in this direction. So if I want to find I source 2, this is going to be equal I3 minus I2. So we have I3, which is equal negative 1.25 milliamps minus negative 11 milliamps, and this is going to be equal negative 1.25 exponent 3 negative. Negative and negative gives me positive, plus 11 exponent 3 negative. This is equal 9.75 milliamps. .75 milliamps. We've found already I source 2, we've found I1, we've found I2, we've found V1, we've found V2, which is simply VAB, and now we're supposed to find the powers. So in order to find the power, I'm going to use the currents. So I have P1 is equal I1 square times R1, where I1 is equal negative 5.33 milliamps to the second power times R1, which is equal 3 kilo ohms. This is equal negative 5.33 exponent 3 negative to the second power times 3 exponent 3 equals 85.22 milliwatts. 85.22 milliwatts. Next I'm supposed to find P3. P3 is equal I3 to the second power times R3. I3 we found this is equal negative 1.25 milliamps to the second power 4 kilo ohms. This is equal negative 1.25 exponent 3 negative to the second power times 4 exponent 3. This is equal 6.25 milliwatts. milliwatts. So in order to find total power, I'm supposed to find also P2. P2 is equal, I found I2, so I have I2 to the second power times R2, and we have negative 11 milliamps to the second power times R2, which is equal 1 kilo. So this is equal 11 negative exponent 3 negative to the second power times 1 exponent 3 equals 121 milliwatts. 121 milliwatts. Right, so if you want to find P total is equal P1 plus P2 plus P3. P3, this is equal P1 85.22 milliwatts plus 6.25 milliwatts plus 121 milliwatts. So P total is equal 85.22 exponent 3 negative plus 6.25 exponent 3 negative plus 121 exponent 3 negative equals 212.47 milliwatts. Okay, and this is my total power. And if it comes to this current, okay, so this current and positive, if it comes to this current, the positive terminal of my power supply, we can say, will push the current in this direction, okay, because we use conventional current flow, and current flows from the positive terminal to the negative. So we can say that the problem is solved.